This is chapter number 18, R.D. Sharma's solution. Class 12 Maxima and Minima, we are taking exercise 18.3. Show that log x by x has a maximum value at x equals to e. Now x equals to e, it is having a maximum value. First step is to differentiate. We will find out the f dash x, that is f prime x, and differentiation you already know how to do this. You can take p by q form or the question form. To take the differentiation, denominator goes square, then the denominator, differentiation of the numerator, which is the log x is 1 by x, subtraction, then the numerator and the differentiation of the denominator. Denominator is x, so the differentiation will be 1. Now this will become 1 minus log x divided by x square. 1 minus log x by x square is our final differentiation. In order to find out the local minima or maxima, we will take this f dash x and equate it to 0. So when it goes, x square will be 0. 1 minus log x is going to be 0. So that simply means log x is equal to 1. When we say 1 minus log x equals to 0, that is 1 is equal to log x. And we already know in terms of log or wherever the log properties comes, log base a b equals to c. This means a to the power c is b. So if base is e, then e raised 1 is equal to x. That means x is equal to e or e is equals to x. This is the critical point for x. The third step comes is the differentiation of the differentiation, that is the double differentiation, f double dash x. And then this f double dash x, after doing the differentiation which I am right now writing, I am not doing it, and I hope you will be able to do this differentiation because differentiation is a piece of cake for you now. This f double dash in place of x, we are going to replace it by x is equal to e because the critical point was x equals to e. And in order to show this as maximum value, we have to show that this value is going to come as negative. That is, we will replace x in the f double dash x, the double differentiation, and when we see it will come as minus 1 by e cube. And e is a constant value, it cannot be positive or negative. But this negative 1 by e cube will definitely be negative. Why? Because 1 by e cube cannot be negative. So this is less than 0. And once the double differentiation is less than 0, that indicates that we are talking about the maximum value at x equals to e. And this is the local maxima when we placed x is equal to e, which we got when we were finding out the critical points. So this is how we have proved that this is x equals to e, double differentiation. We placed x equals to e in the double differentiation value and the value is negative. So this is the reference which you can follow and you can solve it. All these sentences you have to really know and write. Find the maximum and minimum value of the function fx is equal to 4 by x plus 2 plus x. First step, f dash x. Differentiation of this function. Let me write this. Normally, actually the differentiation is quite known to you. So I'll write the differentiation because normally x plus 2 should go up or you can do it by quotient rule. So this differentiation is done. Second step is to place this f dash x is equal to 0. That is, we have to place it as 0. So we are equating this negative 4 by x plus 2 whole square plus 1 equals to 0. What do we get? 4 by x plus 2 whole square is equal to 1. X plus 2 whole square is equal to 4. And x plus 2 is equal to plus minus 4. Alright? It's not plus minus 4, it will be plus minus 2. I'll just change it. There's a slight change, I'm going to do this. So when it is 2, because x plus 2 whole square is 4, that means x plus 2 whole square is plus minus 2. So plus minus 2, so this 2 will go on the right. One time plus, one time negative. So one time you will get 4, one time you will get 0. Alright? So this is negative actually, but because minus is already there on the right. So negative will go on the right and it will become x is equal to negative 4. So you got 0 and negative 4 as the critical points. And these critical points are the point of possibility of local minima or maxima. These are the points. So we will find out the double differentiation. In order to check whether maxima or minima, these points are there or not, or these points signify minima or maxima, we'll do the double differentiation. So 8 by x plus 2 whole cube is the direct double differentiation which I have written. And since there is no interval being given here, there is no say domain or range etc. So we will check at 0 and negative 4. We can take both the values. So we have to check for f double dash 0, and we need to check for f double dash negative 4. And we'll place this 0 and negative 4 in this 8 by 8 plus 2 whole cube. So one time just place 0, the other time just place negative 4. So 8 by 2 cube is 1 only, because 2 cube is going to get cancelled. So f0 is going to be 8 by 8, which is 1. How about negative 4? When we place negative 4, it will be 2 minus 4, that is minus 2. Minus 2 whole cube will be negative 8. So one time you will get 1, one time you will get negative 1. So 1 means greater than 0, it is indicating local minima. Positive always indicates local minima. But negative value in minimum, opposite of minimum is maximum. So the value which is going to be negative will be oppositely matched. Greater than 0, local minima. Less than 0, because we have got negative 1, this is going to be local maxima. So we have to find out the maximum and minimum values, which we found here. Okay, now this 0 and negative 4 has to be placed in the original equation. In order to find out the value of the function at these critical point, we have to place the 0 and negative 4 in the original equation. When you place 0, it's going to be 2. So you can say f0 is equal to 2. And when we place negative 4, it will be 4 by negative 4 plus 2 minus 4. So this is negative 2, and this gets cancelled, 2. So negative 2 minus 4. So you are going to get negative 6 here, which is the value which we have here also. This is the whole explanation also, and for reference who are doing it by yourself. So this is a slight thing which you can ignore. Other things remains the same. So you just know how to write so that you can complete this question. Writing. Find the maximum and minimum value of y equal to 10x minus 2x. F dash x we are going to find out. 10x is sec square x minus 2x, so minus 2. And then second step is f dash x should be equal to 0. Let us place it as 0. So sec square x will be equal to 2. So sec x will be equal to plus minus root 2 that we are witnessing, that we are going to get. So sec x, or if you are aware of, or if you are well versed with cos x, you can write it as 1 by cos x also. So sec x will be plus root 2 one time, and sec x will be negative root 2 one time. These 2 points are the critical points. These critical points have to be checked. For what? F double dash x. First thing is sec x can be 1 by cos x. Cos x is 1 by root 2, and you know it is pi by 4. Sec x is negative root 2. 1 by cos x is, or cos x is minus 1 by root 2. That only comes when it is pi minus pi by 4. That is 3 pi by 4. So we have pi by 4 and 3 pi by 4. These are the 2 critical points, possible points where you can get the maxima and minima. F double dash x we have to find out. That is, we have to again differentiate the sec square x minus 2. 2 will be 0, of course. Sec square x will be 2 sec x, and then differentiation of sec x will be sec x tan x. So this is 2 sec square x tan x. 2 sec square x tan x. And the fourth step is f double dash pi by 4. F double dash 3 pi by 4. These are the 2 values, critical point value, possibility of maximum and minimum. Now this can only be found using the double differentiation. And double differentiation, 2 sec square x tan x, just place x as pi by 4 in the first case. In this, just replace it by 3 pi by 4. So this 3 pi by 4 will come. And you know already that the values of 10 pi by 4 is 1. 3 pi by 4 is negative 1. Similarly, here sec square x is there. So whatever is the value is there, negative or positive, it is going to come same. So the only difference is 10 pi by 4 and 3 pi by 4, which will give you 1 and negative. So the values remain the same. Only the sign will change. So 2 sec square pi by 4 is 1. I told you it was root 2. So 1 by root 2, this root sec square, if you do root 2 whole square is 2. So you got 4. It is local minima. Here you will get negative 4. It will be local maxima. Please again understand, the greater than 0 or the positive value indicates minima, local minima. And the negative value will indicate the local maxima. So tan 3 by 4, let me take you to the actual geometric points. Tan pi minus pi by 4, add sugar to coffee. When you have add sugar to coffee, this second quadrant will have tan as negative. So that is why it is negative. Tan 3 by pi by 4 can be written as tan pi minus pi by 4, or you can simply say tan 135 degree is minus 1 only. Negative means less than 0, and that means local maxima, local minima, local maxima. Now we don't have to worry about these values because these are just for sign. But we have to worry about pi by 4 and 3 pi by 4 because these are the critical points where actual values of the function has to be computed. So we have y equals to 10x minus 2x, 10 pi by 4 minus 2 pi by 4, and the second value will be 10 3 pi by 4 minus 2 into 3 pi by 4. 10 pi by 4 is 1, 10 45 degrees 1, 2 into pi by 4 it can be pi by 2. 1 minus pi by 2 you can just write, this is the final value of the first critical point. The second critical point 3 pi by 4, again just paste it in 10 3 pi by 4 minus 2 into 3 pi by 4. 10 3 pi by 4 is negative value, and 2 into 3 pi by 4 just cancel this 2. So 2 cancel with the denominator, it will be 3 pi by 2. So negative 1 minus 3 pi by 2 is the second value. So this is how you are going to solve it. All the steps are being given. Whatever I have explained is in front of you. Just try it by yourself because mine is logic, yours is writing. X cube plus ax square plus bx plus c has maximum at x equals to negative 1, minimum at x equals to 3. Determine a, b, c. So minimum, maximum is already given. The critical points are already given. And at this critical point, the function has to be 0. So we'll first find out the f dash x because the f dash x has to be 0 at these critical points. So I'm differentiating it. This is the differentiation 3x square plus 2x plus b. Next one will be the minus 1 and 3 value. These two values will make this differentiation 0. That is how we come to the critical points. How do we compute the critical points? By placing the equation equal to 0. So these are the value we have got after placing the equation, the first differentiation equation as 0. So f dash minus 1 is equal to 0, f dash 3 equals to 0. So take the differentiation expression, put minus 1 in it and find out the equation. There will be an equation being formed. Again, place the value 3 in place of x and see what value comes. So 3 negative 1 whole square plus 2a into negative 1 plus b is equal to 0. So this equation will be simply this 3 minus 2a plus b is equal to 0. The next, this equation is there. The second equation will be by placing 3 in the differentiated equation. 3 into 3 square plus 2a into 3 plus b. So this was actually equal to 0. This is 3 9 is 27 and 6a plus b. So we have two separate equations and you see we have 3 variables but we have 2 equations. There is no way we can find out the third equation or we can come up with the third equation. So let us deal with these 2 equations and try to find out what can be the values a and b can be found out. Okay. Now I have just re-verified it and just subtract these 2 equations. When we subtract this b gets cancelled. 27 minus 3 is 24 and 6a minus 2a is 4a. So we have 24 equals to 4a. 8 is, it was negative 2a. Okay, please remember that is why it became plus. So you have to subtract 6a plus 2a, it will become an 8a. So a is equal to minus 3. Now place this a equals to minus 3 in any of these 2 equations. When we write a equals to minus 3 in either of the equation, for example, I am writing or replacing a equals to minus 3 in the first equation, we get 3 plus 6 plus b equals to 0, which gives b is equal to minus 9. A, B, C. There is no way we can find out the value of c because the number of equation decides how many variables can be solved. 2 equation, 2 variable. 3 equation, 3 variable. Where is the third equation? There is no third equation, or we can also not come up with the third equation. I hope you got the idea. So you can just write that c is belonging to real number because any number can only belong to real number because there are different subsets of real number. Real number is the biggest set. That is why we have a and b, minus 3 and b equals to negative 9. But c cannot be found and this is simply belonging to real number. So this is the minimum maximum at negative 1 and 3. This is the main key point here, which tells us that we have to take the differentiation, equate it to 0, and this will only come 0 when we have 1 and negative 3. Sin x plus root 3 cos x has maximum value at x equals to pi by 6. This means the maximum value at x equals to pi by 6, the differentiation of this equation, when we place x equals to pi by 6, it is going to give you 0. This is the only justification of this question, and that is the solution also. Fx is there, just take the differentiation f dash x. When you take the f dash x, it will be cos x, and cos x will be minus sin x, cos x minus root 3 sin x. Now second step is to place f dash equals to 0. Now it is already given in the question that as x is equal to pi by 6. This is the critical point already being given, and already given that it will give you maximum value. So we will place pi by 6 here, and since it is maximum value, we don't have to worry about anything. We just have to take the double differentiation, and since we have to prove, we'll take the double differentiation and we'll place this pi by 6, and we will say that we are getting a negative value. What I'm trying to suggest here is double differentiation has to be done. We don't have to place f dash x equals to 0 in this case, because double differentiation is minus sin x minus root 3 cos x, and in the place of x in the double differentiated equation, we will replace it by pi by 6. Once we replace it by pi by 6, we will like to know whether the sign is negative or positive. If it comes as negative, it will be maximum. So let us see. Sin pi by 6 minus root 3 cos pi by 6. Pi by 6 is simply 30 degree. Sin 30 degree, and here cos 30 degree. And these values are quite known to you. It is half. Sin 30 degree is half. Cos 30 degree is root 3 by 2. So we have minus half, and minus you can take common. Half minus root 3 becomes 3. 3 by 2. 3 plus 1 by 2 is 4 by 2, that is 2 gets cancelled. You get negative 2. So negative 2 is less than 0. And this shows this minus 2 is less than 0. Negative means we will have the maximum value. And that was we were interested in. We wanted to show that it is negative. And same thing is being done here. Only double differentiation and putting this pi by 6, we will tell you that it is negative, and negative means point of maxima. So this is all about this exercise. Thank you so much. Take care of yourself.